Okay, so I'm absolutely delighted to be on this Zoom call here with Dr. Peter Apps because I'm going to let him speak and I'm going to let him explain, but because his work is something that I am absolutely in admiration, I've had the highest admiration for. It involves predators, it involves prey, livestock animals, it involves conservation, it involves joined up thinking to create a result that I consider to be absolutely groundbreaking in what Peter and his scientific research team have managed to achieve and are working on. But I'm just going to, for anybody who doesn't know Peter or Dr. Apps, I don't know how you prefer to be
Peter,
known.
please,
Peter.
please, Peter.
Peter. Okay. A humble,
I'm Doctor.
a
I
humble
am. I'm.
scientist.
Yeah, I'm Doctor Apps when I'm interacting with the government.
Okay, Peter, if you can just introduce yourself first of all, who you are, your background, how you've come to be where you are, and we'll take it on from there.
Okay, thanks, Jamie. Thanks for making the time to have me on. Yeah, life history. So starting at the present and working back's probably the best way. At the moment, I'm running the Bioboundary project, and I'll explain exactly what that is a bit later, which is a project of the Botswana Predator Conservation Program of Wild Entrust Africa. It's Wild Entrust on the shirt there, and you can Google them. You'll get to the website. You'll see more about what I'm going to be talking about. Now, the Bioboundary project itself started in 2008 when I moved up to Botswana to set up an analytical lab and a field research program to look at scent marking in large carnivores. There's lions, leopards, spotted hyenas, cheetahs, and African wild dogs. And the idea was to identify the active ingredients in their scent marks, especially the ones that they use to demarcate their territories, and to use a simplified, stripped down version of those scent marks, reconstructed from artificial ingredients, to keep wild dogs inside protected areas by creating an artificial territorial boundary along the designated border of the wildlife areas. And then later on, it evolved into a parallel project to keep large predators and now also medium-sized predators away from livestock. Now, the reason we want to do that is that conflict killings of predators by farmers over the predators killing livestock is the major threat to predator populations worldwide. And it's tied with habitat loss, but habitat for a predator really has to include freedom from persecution by people who are trying to protect their livelihoods. These are not farmers who are going out persecuting predators for the fun of it. They are forced into it basically by the losses that the predators inflict on their source of livelihood. So that's where I am now.
So
Previously,
before you
yeah,
before you
okay.
carry, oh, I think you might have just been about to do it. I think you might
Oh,
have
no,
just been
it's
about.
good. Yeah.
I was going to say that there is so many for you. This is a sort of like a sort of like series of events and series of happenings and expertise that you're involved in. So I'm going to try and break this down for the layperson who might be listening, who might not necessarily understand some of the terminology that you're talking about. So as
Okay.
as a professional, what is your professional background to be able to get yourself into creating, if you like, artificial scent markers and to understanding how to do that? And obviously we'll break that down as we come along. But what is your actual your area of expertise, your specialism?
Well, it's a very unusual, in fact, these days almost unique combination of analytical chemistry in organic chemistry, mainly on things like flavors and off flavors, a little bit of work on pesticide residues as well in human foods. But those analytical techniques are exactly the same ones as you use to analyze mammalian scent signals.
Okay.
They're exactly the same. The mammalian scent signals are a bit more challenging, but the hardware, the instruments we use, the techniques that I use are exactly the same for both. So that's my analytical chemistry background. Then going back before that, I'm a zoologist. So I got a BA in zoology from Oxford way back in the 1970s. Then I went to Pretoria University, worked on feral cats on Dasson Island for 18 months, got an MSc for that. And then I got into a chemistry lab because my funding had run out. This will become a recurrent theme as we go on.
Okay.
Funding running out. And then I kind of stayed in chemistry. I got my PhD in zoology, but a lot of it was quite innovative chemistry, working out new techniques how to analyze mammalian scents. So then I went from mammalian scents doing my PhD. There's no money in that, so I went and worked in pure analytical chemistry labs in food residue work. So looking at pesticide residues, veterinary drug residues. So it's trace analysis in complex samples, which is what mammalian chemical signals are. Did that for a while. I got headhunted between various labs who needed my specialist expertise. Ended up at the CSIR in South Africa working on off-flavors, and then went to the metrology lab in South Africa doing kind of high-level, very precise quantitative analysis. And then I got headhunted up to Botswana by Tico McNutt, who's one of the directors of Wild Entrust. That was in 2007, 2008. So that's my life, how I got here, more or less.
So that's a pretty phenomenal back catalogue of, qualifications and experiences, and, your life journey is pretty phenomenal in itself. And when you talk about field work, people think of a scientist as working in a laboratory. What is field work? If you could just explain what you mean by that.
That's also quite varied. So the kind of classic field work on large carnivores is stuff like radio tracking, these days with GPS collars, and a lot of those run through satellites. So there's actually quite a lot of so-called field workers who sit in an office looking at a computer screen all day and the data just flows in. I'm not one of those, but we do use remote tracking. We do direct observation, especially with the wild dogs, because we have to follow them around in order to find the places that they scent mark. But a huge chunk of what I do is camera trapping. We use camera traps to monitor the reactions of the predators to the artificial scents that I create in the lab. And also, to some extent, especially with African wild dogs, to record their natural scent marking behavior, because we need to understand that in order to design our deployment strategies for the artificial scent marks.
So in a nutshell, you will monitor or set up cameras to see how large predators will mark specific boundaries, specific areas of their territory, I take it.
Yes.
And that scent marking will serve to repel competitors. Would that be a way of?
Pretty much, yeah. Typically, the scent marks are not actually repellents. I kind of use the word repellent quite loosely, I'm afraid. At short range are actually attractants, because what each pack of wild dogs, for instance, wants their neighbors to do is to come to the scent marking sites, and there's an interesting story behind those as well, which we might have time for, is to actually be attracted to the scent marking site and to read the scent messages which are there, at least some of which say, okay, guys, this is our mutually agreed border. So you leave your scent here and we'll put our scent here. And then everybody knows what's going on. We know you, you know us. You've got your home range, we've got ours. Let's not trespass much past this line, and then everything will be peaceful. If you decide to ignore that warning and we catch you inside our home range, we're going to beat the shit out of you, basically. That is how territoriality works. Territoriality is actually dominance in space. I know dominance, the D word, is a dirty word in dog training. We know this. But territoriality is actually on A dominates B in A's territory and B dominates A in B's territory.
Okay. A bit like
As they cross
gangs,
the
a bit
line
like
there.
gang, like the old
Well,
1970s New York
exactly,
gang scene.
exactly. This is our turf.
Yeah.
That's your turf. We don't go there because you'll beat us up, and vice versa. Same thing with mammal territoriality, and the mutually agreed borders are demarcated with scent marks, which stripped down to the absolute bog standard basics say keep out.
I was going to say, I
And
mean, if
that's
you if it's using your gang analogy, that's basically like your graffiti on the
it's the
wall of this is the
graffiti.
borderline, but
That is the exact analogy. If one gang wants to challenge another, what does it do? It goes and sprays its tag over the other graffiti. Same thing, very similar stuff goes on with scent marking. You get what we call overmarking or countermarking. So if there's pressure on the territorial boundary, it will manifest as the prospective intruders. They will be marking over the marks of the residents. There's all kinds of really interesting, complicated behavioral stuff goes on, and the chemistry is even more complicated.
so if
Um,
I take it to the point there where you're, I mean, obviously you're studying canids and felines as well, so you're seeing the same
yeah,
sort of behavior across, a different species, if you like, or
yeah,
within the, within.
and hyenas as well.
Okay,
So,
okay. So
so
they
it's
all carry this similar
the
sort of characteristic, this similar trait to be able to mark territory
yeah, pretty
boundaries.
much. Yeah.
Yeah.
Most carnivores are territorial, at least to some extent, and they all use scent marks to demarcate the areas in which they live. And then the extent to which that creates hard borders varies hugely between species. Some have a lot of overlap, others have nearly none. And that also varies within a species between habitats according to how much resources are available and how the resources are distributed. So, no, the bioboundary for the wild dogs, for instance, when we do create it, we're not expecting dogs to bounce off it like they
Yeah, yeah.
would off a physical fence.
Fence, yeah.
It is something which reduces the probability that they're going to go further beyond where we've put our artificial scent marks.
And so in order to, somebody would say, how do you know this? How do you know that this is what has happened? But where you say you've put up the camera traps, I'm assuming that you've monitored marking sites over a period of time and you've observed the behavior of the predators that choose to ignore or that choose to adhere to the marking given to be able to determine the purpose of it.
Yeah, pretty well exactly that. The wild dog marking sites, we actually discovered them in 2015. Before that, nobody even knew they existed. This was one of our research assistants in the field, spotted a dispersing group of wild dogs, not even a pack, but they were scent marking at a particular road junction. And then about a month later, there was a pack of dogs there sniffing and marking at the same spot. So this was a real light bulb moment, because now we've got GPS and it was at a landmark. It was obvious this is actually exactly the same spot. We put a camera trap there and it turned out that there were 4 different packs all using that one spot. So this was a huge breakthrough. Now, the odd thing is when you think about how many researchers have been working on wild dogs for how many decades in how many countries, and nobody had ever spotted that they use these shared marking sites. Now, initially we thought, okay, maybe it's only in our area, but they've since been discovered elsewhere. We thought, maybe each pack has one marking site with each of its neighbors, so there aren't very many. That's why nobody ever found them. But in fact, each pack has probably got a couple of dozen around the fringes of its home range. So it wasn't that. It was just that partly, I think, you need a GPS to get the exact fix so you can be sure you're absolutely at the right spot. But also, people tend to miss what they don't know to look for.
Yeah.
But anyway, that's a little kind of byline. So yes, we've got since we did a year's camera trapping at that first site. Then we didn't have funding, recurrent theme. Then we got money in 2019 from St. Louis Zoo Wildcare Institute and hugely expanded the camera trapping. And Megan Classer, who was the field researcher who discovered them, she'd actually gone away and come back again. And she's done a doctorate on this, published 4 or 5 papers on it. If the people go to the Wild Entrust website, there's a list of the publications there.
I'll put a link.
So
I'll put
they'll
a link on
find,
the comments here or in
oh,
the description of this video. I'll make
yeah,
sure every link is there for people
it,
to be
yeah,
able to
it
take a
pops
look.
up on Google just fine. And yeah, so it's about which sex marks the most and which sex marks over, and is it to do with dominant status? Because wild dog packs have a very, very, very definite dominance hierarchy, kind of upside down to what you'd expect, but it's there. So it tends to be the dominant pair that mark the most. They will overmark one another. Typically, the subdominants don't mark very much and they don't overmark other dogs, all this kind of stuff. So you put all that together and you come up with these things are home range boundary markers. For a start, I mean, the strongest evidence is that all the marking sites, the shared marking sites, are in the areas where adjacent home ranges overlap. So that tells you, okay,
Yeah, it does. Yeah.
and they're all used by multiple packs. So what is one pack got to say to the next? Basically, we're here, you're there, it's all fine. In addition to that, of course, okay, nothing's ever so simple. You've got these disperser groups of wild dogs because as the packs get bigger, they start to bud off disperser groups of single sex. They're looking for a place to settle down, meet some mates, carve out a territory and start a pack of their own. What those dispersers do is they go to the marking sites to check which packs have got prospective dispersers in them. And they'll leave their Tinder profile there. I mean, this is pretty much it. Yeah. And so then when the pack comes around, say a bunch of males have come through, dispersers, 3 or 4 of them maybe, they've left their Tinder profiles at the marking site. When the pack comes along, the young ladies of the pack who are thinking, if there were some nice boys around, I might disperse, they will pick up that Tinder profile and then overmark it. Then those dispersers come back again. Say, oh, okay, I've got a
Somebody's checked out my profile.
Whatever it was, I'm not on Tinder, but
nor am I.
That kind of thing. Okay,
yeah.
This is encouraging to know. And they'll communicate back and forward, pretty well in the cento net, right? They've never met. All they've done is communicate by chemistry. And then, depending who's living where, the ones that are in the pack will start to kind of bud off. They'll go out looking for the dispersers. And then they'll come back again to the pack, and then they'll go out again if they meet the dispersers. Huge amounts of scent marking, overmarking, lots of mutual body rubbing and all kinds of stuff like that. Sometimes that pack sticks. Other times they split up again. Everybody goes home. All kinds of stuff, which we pick up on our camera traps in hugely greater detail than anybody gets with direct observation. Because, of course, the camera traps are right there where every single wild dog in the area inevitably goes, because it's a marking site. They are the absolute hubs of African wild dog social life.
That's incredible. It's like a nightclub or something where, the groups descend and you see, should you and I, and you exchange these keyword signals or whatever.
Yeah, it is. But the critical thing is that initial contact is not in person or in dog. It is done only by chemical signaling.
So you then, so to move this on, you having recognized, and sort of like been pioneers really in recognizing these are scent marking sites. This is how they are communicating. This is what they are doing. And this is you see value, or you saw the value in that, to be able to say, well, hang on a minute, if we can replicate that scent, and if we can sort of like produce it in a a false form, if you like, or a non-natural form, we can then use it to be able to work. How would you, just to explain to people, how would you take that from, predators that are marking at scent sites and take that to go to protect livestock from attacks by those predators?
First thing is the actual scents themselves are hugely complicated chemical mixtures. There's easily 300 or 400 different chemicals in any piece of dog poo, your dog's pee, human pee, mouse pee, poo, doesn't matter.
Yep.
Body odor, hundreds and hundreds of different organic volatiles. It's completely impractical to make a facsimile copy with everything in it. It would cost millions of dollars and take way too long. You could never produce enough of it.
Yep.
So my approach is, if this is going to be viable, you have to strip that signal down only to the compounds that are sending the actual keep away signal, because otherwise it's just not viable. There's no point. If it needed whole scent facsimiles, it would be impossible. So why even bother thinking about that?
How on earth does a human being get some wild predator urine as a chemist and know these are the actual parts of that
Okay,
compound
so
that actually mean keep away? How do you do?
yeah,
Do you test
right.
them?
Well, yeah, in a way. So let's go back to the wild dogs, right? So for the wild dogs in specific, they they respond reliably at their scent marking sites to scent which is at the scent marking site. If you collect scent from the places where they rest, so during the day they're lying in the shade having a snooze, every so often they'll get up and walk 3-4 meters and have a pee
Yeah.
or a poo. You collect that stuff and you present that to wild dogs, most of the time they are completely uninterested. It's as if there's nothing there.
Okay.
If you present scent from a scent market site, it's, oh, okay, this is interesting. We better pee over this or give it a good sniffing at least. So that tells me that what's at the scent market site has got some components in it which are sending the keep out signal, the territorial boundary marker, which is not in the stuff which they are just pooing and peeing in the resting sites. So chemical analysis, you just compare the two, preferably from the same dog collected within a few hours of one another. What's present in the marking site marks and not present in the resting site excretions, those are candidates for testing. So I had a short list of 6 of those, of which 4 I had definite identifications for, confirmed with proper confirmations. I had one I thought I knew what it was, but another lab using a more sophisticated technique said, no, it's not that, which is good because I was about to pay somebody to synthesize it. And then the other one, we don't know what it is. Now, the 4 that I know what it is, buy them in bottles, test them, the dogs are completely uninterested. So that didn't get us very far, but we still got 2 on that list, which, now when funds are available and everything's running right, I will get back with the natural products labs to get proper identifications. But in the meantime, I've been testing other components of various scent marks from various species, including wild dogs. And we now have, for the first time ever, I mean, nearly everything I do, I want to stress, nobody's ever done before. Certainly not with wild animals. So we've got the first ever reactions of a wild, free-ranging African wild dog to a single component of wild dog scent. I posted that on YouTube somewhere that people
I was just going to say, if we can get a clip of that,
yeah,
we'll bring that in, and so that so everybody, because everybody needs to see that. I mean, that's incredible.
And the interesting thing is that the response is an overmarking, which is completely indistinguishable from the natural reaction to a full natural mark with all the hundreds of components in it. So that's wild dogs. That's where we are at the moment. We got reaction to one compound, which my suspicion is purely a suspicion. It's not actually the keep out compound, but we need a lot more
Bonding.
data before that feeling is based on evidence. Now, with the keeping away from livestock, this is the other bit. So far I've been talking about African wild dogs, where we want to make a perimeter boundary around the protected areas, keep the dogs inside. There's a whole lot of carnivores, especially in Botswana, that live in the livestock areas. They coexist with livestock and the livestock owners. And every so often they will kill livestock, and then the livestock owners kill the predators. If we can stop the predators from killing the livestock owners, they're perfectly happy to have the predators there as long as they're not eating their cows and sheep and goats. The approach there is also doing the kind of strip down technique. So we want the absolute minimum complications in what we're going to use as our final mixture. So in other words, we want a single compound. Now we struck, once again, as we discover in the African wild dog scent market site, we struck lucky in that I did a little feasibility study with half a dozen camera traps and some little slow release scent dispensers that I wanted to test, with one component of leopard urine, which is also found in tomcat urine, called the tomcat thiol, interestingly enough. You can buy it in a bottle. So I thought, okay, for a feasibility test, proof of concept, let's see if the hardware works, all this kind of stuff. I'll test this and see if we get reactions maybe from leopards, but African wild cats, same species as domestic cats, maybe they'll react. They did, but that's not the interesting bit. The camera traps are out there for something like 4.5 months. And in the last week they were there, we got a camera trap video of a female leopard, and she walked into the field of view. This one's also on YouTube. If people go and look on my channel, they'll find all of this stuff. Female leopard walks into field of view. She gets into the scent cone from the scent dispenser. You can actually see from the way the grass is blowing which way the wind is coming. She hits that scent cone. She grimaces as if she's got a nasty smell in her nose and does a U-turn. And this was another one of these, okay, we need to look at this in serious detail. So I did a whole bunch of expanded that, did a whole bunch of more tests, some negative, some positive, etc., etc. Now that work has now moved from the protected wildlife areas where it started out into the ranches and subsistence livestock areas where the conflict is actually happening. So what I'm doing is a kind of 3-phase process. The first is using controlled release dispensers, which are actually really, really simple technology. It's a plastic tube with a membrane over the top, and the smell diffuses out through it extremely slowly. We're talking about release rates of micrograms per hour. So the exposure of the animals is nearly nothing. A human can walk past any of these things. They smell nothing. So there's no point having a repellent for a predator, which repels the people just as well.
Yeah.
So this is, it's at realistically low emission rates. I test these things basically one at a time with a set of camera traps on 3 different ranches out in the livestock areas. And if I get positive looking reactions in terms of animals are repelled by this, or if there's a sudden drop in the number of carnivore videos I capture, which suggests that they're being pushed away outside the camera trap's field of view, then okay, that one's worth testing further. What I then do is I put that same compound, same release technology, on fences where there's a gap underneath where the predators are going through, because most of the fences here are quite porous. Put it there and see if it will slow down or stop predators. If it does, next step is we put them on fences around livestock enclosures. See whether that makes any difference. We're still at that stage monitoring with camera traps, see if we're getting predators turning away, this kind of stuff. And also, we make collars for the livestock and the scent dispenser goes into a housing on a
Oh,
piece of
wow.
rope, and that gets
Wow.
tied around the animal's neck. Because obviously the problem is where the livestock is. It's not at the fence
Yeah.
per se. And that works incredibly well. We've now got repeated cases where people have been losing livestock to predators. One or two a week is fairly typical. Our most extreme case was somebody who was losing one goat a day. I mean, that's basically his livelihood is being stripped away.
Yeah.
We put these collars on, and typically we put them on a half, maybe 1 in 3, sometimes 2 in 3 of the flock, concentrating on the vulnerable size classes. And the predation just stops. The next day, the predation stops completely. Now, there's basically no other intervention, no other non-lethal intervention, which works as effectively as that. um, and
How long, if I can just stop you there.
yeah,
So, just to sort of like summarize again for, normal person in the street, you synthesize the components and test the components of the predator urine, and you put them at sites where you have cameras that can see what do the predators do when they approach this urine. And you've found, like with the leopard, was it with the leopardess that or with the leopard, that the camera actually caught the leopard turning away. So you said about the scent cone, for people who don't know. So a scent cone, if you're looking at like the shape of a triangle or a megaphone, if at the point of that triangle is where the scent is, the cone would be the area that it diffuses out from. Would I be right in saying that?
yep,
So the animal
absolutely.
might smell it here, which is where it's
Yep,
coming out. So it's coming out narrow and then larger, and the animal smells it from back here in this sort of like cone-like shape, and it repels the animal. The animal moves away. You've then
yep,
taken those same, the ones that are effective, you've taken them and you've put them at, if you like, a natural thoroughfare, a natural alleyway, a natural entry point underneath the fencing or through flaws in the fencing to see whether it will repel there. And then you've taken them and put them around the livestock area, or you've also put them on the actual livestock themselves, the same scent on the livestock themselves. And the
yep,
success rate has been that it has overnight deterred predators from attacking those livestock when they're wearing
yep.
this particular scent. Would that be correct?
That's absolutely correct.
That's
It
phenomenal.
just switches the predation off. We've had livestock owners tell us in that, now I'm quoting their exact words, it looks as if my sheep have made friends with the predators.
That's incredible.
They
That's
say
insane.
they find leopard tracks walking past their sheep enclosure.
With no
And the
attempt to
leopard
actually go
is
in.
typically, you'd expect that leopard to jump in, kill something, and take it out. The leopard walks past without killing stuff. We've had one, so on one ranch, we've had these deterrent collars um, on sheep and goats since July last year. So we're getting on now for 18 months. No losses to leopards in that
No,
whole time.
no way. In 18
Yeah,
months.
none. Yeah, no, zero losses. Now, of course, the expectation is that the carnivores will habituate. They will get used to any measure that you do. Flashing lights, noises,
Yeah,
anything
yeah,
you
yeah.
do, except bullets and poison, of course. They get used to it and then they go back to their old ways. We've had 18 months with zero losses to leopards on this one ranch. And we know for a fact that there are 4 different leopards living on that ranch because we see them with our camera traps. But none of them eat mutton anymore.
That is because I,
Now,
I know.
if
Sorry, carry on.
if yeah, if we had not put the deterrent collars on the goats, all of those leopards would have been killed by the farmer. So there are 4 leopards walking around there who owe their lives to the bioboundary deterrents on the sheep and goats on that ranch. And that's just one ranch. Right?
That
What
in
we're looking to
itself,
do now is
Peter, I mean that deserves some recognition. Is if you've got a world that is absolutely fascinated by protecting and conserving wildlife species, endangered species. And you're saying that the work that you've done over an 18-month period for leopards are living
Yeah,
literally by
yeah.
virtue of the work that you've done. And I mean, that
That's
must be a phenomenal feeling.
and and then that's not counting the leopards in the subsistence areas. We're probably looking at 2 or 3 individual leopards there, which, if we had not protected those flocks using the deterrents, the farmers would have poisoned them or shot them.
So why isn't your work getting the kind of, I'm going to come on back onto this work when you see about the band trophy hunting and all this and the amount of sort of like global press coverage and donations that gets. Here you've got something that is basically protecting living animals. Again, it's a conservation effort that's it's successful. It's proven it's successful. It's
Yeah.
non-invasive. Why
Well,
aren't you getting the sort of funding stream and media coverage that they get?
I wish I knew, Jamie. I really wish I knew. I mean, I don't want to give the impression that we've never had any funding. We got very generous funding from St. Louis Zoo. We got funding for 1 year, at least, from Oppenheimer Foundation. There's small organizations like Stichting Spots in the Netherlands, which channels money from WWF Netherlands to us. We get donations from private people like Janie Overbosch is just now giving us some more money to keep parts of the project going.
But
We
this
get
is
money
something that
from SIVA. So there's money coming in. I don't want to give the impression that
no, you're not
nobody's
giving that. You're
paying us
not giving that
anything.
impression. You're not giving that impression. But I
But,
do think
but
that there's a whole celebrity world
yeah,
that could be
you
endorsing.
would hope.
Yeah,
You would
yeah,
hope.
yeah.
But we've never really had enough to expand this to the scale it needs to be moving at now, to make it big enough that the data is really flowing in, and that we can run replicates of things in parallel rather than doing them one after the other. So everything starts to run more quickly. And no, I'm I'll confess, when I first put the collars on, I thought, maybe we kind of cut predation by a half. And even that's wonderful. Nobody else can do that. It just stops it completely. And we've done it repeatedly now. So it isn't a freak. And it's been done in not exact predation tests, but the effects going through fence gaps. That's been replicated in Namibia and Kenya. Protection of livestock has been replicated in Botswana and Zimbabwe. And I'm just now in the middle of a project in Nepal where we're seeing quite dramatic effects on tigers. Tigers doing U-turns when they smell deterrents in screening tests. Those videos are not up yet. One day they will be. Maybe that will get the exposure. And so this isn't a little flash in the pan. It worked once, probably it's not going to work the next time. We now have multiple incidences where we've put collars on especially subsistence livestock. It has solved the predation problem, and the people then don't go the usual route of shooting, poison, snaring, whatever else they need to do to solve this predation problem.
And is it something that needs to work, or you would think would work best in conjunction? So the livestock wearing the collars plus the boundary dispensers, or do you think the livestock wearing the collars is sufficient without the need to have them signposted around the actual?
Well, yeah, they're complementary. The bioboundary, the one for the wild dog, is really that's aimed at keeping the established packs safely out of the way of people, because to a very large extent, African wild dogs are the big bad wolf. It doesn't really matter whether they kill things or not. The farmers are going to kill them, and they're very vulnerable. They're actually extremely dumb. They don't seem to realize that people are dangerous. So they'll lie in the road in the middle of the day, and the farmer pulls out his rifle and shoots them. And when he's got kind of half the pack lying dead, the other ones catch on something's not right here and they run away into the bush. So they are very, very vulnerable. They are best if we keep them inside. But there's a whole lot of all the other species except lions. So leopards, spotted hyenas, brown hyenas, the medium-sized predators like black-backed jackals and caracals, they're living outside the wildlife areas in very decent densities we find on our camera traps. There are viable populations of those living outside wildlife areas, and those are the ones we need. They can live there, no need to bioboundary them out, as long as they don't kill livestock. So that's where the collars come in. And maybe around the nighttime enclosures on the fences. But my feeling is if the animals inside have got their collars on, you shouldn't need something on the fence as well, but who knows?
And why
Maybe
not? And
one
why
kind of
not?
odor on the fence. Yeah,
Yeah.
one kind of odor on the fence, another one in the collar. Who knows? I mean, I'm just starting with this. You know, it's some of our funders have said, "Oh well, when you've got a final product, come back to us. We'll give you money." As well, thanks, guys. When I've got a final product, I won't need the money anymore.
Yeah.
Because I mean, this is the other aspect to this, right? Mammalian chemical signaling was a quite prospering field in the, say, 1980s into the 1990s. And it's dwindled away dramatically since then, to a large part because there doesn't seem to be a practical application. If you contrast it with insect pheromones, so this is insect chemical signals, it's a huge industry. They use artificial pheromones to disrupt mating or to attract things to traps, all this kind of. You can buy cockroach traps with cockroach pheromones in. The cockroach goes in, gets stuck in glue. That kind of application. It's a massive industry. There's no equivalent yet for mammal chemical signaling. But predation alone, you're looking at worldwide losses in billions of dollars and probably hundreds of millions of dollars being spent on anti-predator measures, most of which are not very effective. So there's a huge commercial market here. So we need a bit of entrepreneurial mindset rather than the sort of timid incremental stuff that tends to go on in wildlife research, where the funders are nervous about actually supporting anything genuinely innovative. I mean, this was the huge breakthrough for me, was the Wilderness Impact Award, which was specifically aimed at innovation for wildlife conservation, and it was a competitive thing. So I put in my application, and Wild Entrust, the bioboundary project, my application, we got the money. And that's keeping me going for another year and allowing a bit of expansion. Now I can do lions in one of the wilderness safaris concessions. I haven't done lions so far because there are no lions on the ranches, which is where I do my screening. So now things start to tie together. So there's very little appetite for genuine innovation, high risk stuff. They want it kind of incremental and safe. But if there is an investor out there with a bit of tolerance for risk and not wanting a strict timeline, I could make him rich.
Yeah, you're the man. Yeah, you're the man.
Because and at the same time we're using, as you say, ecologically benign, non-invasive, low-tech, cheap means of mitigating human predator conflict. So
Well,
it's a win.
you're
It's a
using
win from all
yeah,
directions.
yeah, and sort of like manipulating a natural
Yeah.
repellent in order to protect animals. But I don't really see where the loss is here, Peter, on any sort of like ethical, moral wildlife or whatever. I don't see any negative. I've seen collars in the research because obviously I've looked at electronic collars with dogs and predation towards livestock in the UK and elsewhere, and my own sort of like digging has uncovered cyanide collars in the USA that were so here you're talking about having livestock that are wearing repellent collars in the
Yeah.
USA that trialed livestock that are wearing cyanide capsules. So it's
Yeah.
basically one
They
bite and you're gone. That's the way of dealing
basically.
with
Yeah.
dealing, which if you have a predator species that isn't particularly in need of protection, if you're talking about cockroaches, okay, fine. Perhaps somebody might think, yeah, kill the cockroaches. It doesn't particularly matter. But when you're talking about species that, in their own right, they're only carrying out natural instincts towards animals that arguably wouldn't naturally be within their, on their menu, if you like, apart from people come along and put them there. But I mean, I think it's phenomenal. I genuinely, this is why I really, really wanted to have this chat, and also to try and give the opportunity to get that additional funding, or somebody to step forward and think this is a bloody good idea, and it's proven, and it's got legs. It's going to go somewhere, like you say, without being overly cautious. If I was a wealthy man, I'd be investing myself. I tell you that now. But it is not sort of like pussyfooting, but thinking, go for it. There you go for it, because you've shown that it does it. As you say, the awards, the award that you've won for conservation. I understand have you published papers yourself as well on the findings
Yes,
so
yeah.
far?
One of the drawbacks we've got is that um, the kind of research, this very, very early stage research, it's sort of case studies.
Hmm.
It doesn't fit the current kind of big data paradigm, which is what wildlife research has become, where people collect masses of data remotely, run a whole bunch of statistical so-called models on them, and then publish the model outputs. I mean, that is the kind of baseline, that's the paradigm for wildlife research at the moment. And harsh though it is to say, it's not getting us anywhere.
Yeah.
That there's all kinds of models about this is animals' distribution, this is where it will be under these scenarios of global warming, etc., etc. That's written up as a paper. There isn't anything about, okay, so these animals, the climate zone that they're comfortable in will move from a protected area into an area with people in it. This is a problem, okay? So the people are very, very good at identifying problems, right? Climate change is a problem. Human-wildlife conflict is a problem. Whatever else is a problem. And then they go and they measure exactly how big a problem it's going to be, or is already. So they measure it, and then they make models to project how much worse it's going to get under different scenarios. Nowhere do you see, we're going to come up with a solution.
Yeah. Forget that.
It just doesn't happen. It just is, we measure problems.
Yeah.
It's getting hot or cold or dry, or boy, there's people moving in or animals moving out, or this imbalance here, blah. And now we know all about that to the second decimal place. Solutions? Nope, sorry guys, we don't do those.
But where you're coming up with something it's innovative, it is literally like, yeah, isn't it?
It's brand new. I mean, we're kind of the first guy to get a heart transplant. He lived for, I think, 8 days. We're kind of at that stage. Maybe a bit better than that. Now, if you look at, we're beyond, say, discovery of penicillin was, Fleming looked and he saw the little clear zone. That was kind of the first videos we got of things doing U-turns, and we're now at the stage of Fleming's later experiments where he'd extracted the juice from the mold, all kinds of stuff. That went on to be antibiotics. We're at that kind of stage. Heart transplants, organ transplant in general, that is now, oh, my heart's a bit dicky. Oh, we'll give you a transplant. It's a routine. No, it's not quite in and out in one day, but I mean, I've had my heart fixed. It was literally in and out in one day.
My son had the same. Quick.
So it needs somebody with long-term vision, right? So we get away from this. Typically, wildlife grants are kind of structured around first world students doing PhDs or MScs. So the money is for 1 year or 2 years, sometimes 3, and then that's the project. And that project gets done and it gets written up, and then another one comes in and does another slightly different project. Always incremental, building on what we already know, so we can pretty well guarantee the results before we start. No, this needs a long-term mindset that we're going to have to kind of dig into this and put stuff in and keep plugging away. I mean, I've been working on this since 2008, earning probably less than half I would if I'd stayed at my old job. So I got quite a bit invested already. So yeah, it needs that long-term mindset and genuine entrepreneurial look. Some of this is going to work, some of it's not going to work. It's not a disaster if one particular bit of it doesn't work quite as well as we thought. As long as the main thing keeps pushing towards an economically viable thing so that it can be embedded in local economies. Because what I don't want is that this is permanently dependent, that the actual use of the thing should not be dependent on donations of foreign money.
Yep.
Because then when you get a change of politics somewhere or you get economic chaos somewhere else, it all falls apart. It's happening as we speak with a lot of programs. It must be embedded in local economies. And it must be viable for small livestock owners, small-scale livestock owners, to spend their own money on buying these things to save their own livestock so they've got more to sell at the end of the season.
Yeah.
And then they can send one extra kid to school and probably buy some better quality breeding goats, and they can buy their deterrents for next year. That's what it has to be. If it's something which is always dependent on foreign money coming in, basically that's not actually long-term sustainable. It is too dependent on what's happening in the rest of the world. And certainly bioboundaries, even at this stage, we're looking at payback times of weeks. So if you put deterrents on a flock of, say, 24 goats, there will be, say, 6 extra young goats that could be sold at the end of that season. That way more than recovers the cost.
Yeah.
Whereas if you look at
that surely needs to be put out. People need to know that as well, don't they? That needs to be.
But it's not. You see, isn't the kind of stuff that the scientific journals will publish.
No.
So then because I don't actually have that hard data, it's a reasonable expectation. So yeah, I mean, this is partly why we need somebody who's got a bit of a spark and who's also somebody wants to stamp his name on something that the experts said was impossible. Because the experts in mammal chemical communication, when I first kind of aired this idea, the prevailing orthodoxy was that this will never work because everybody knows that mammalian chemical signals are these complicated mixtures and they don't work if you don't have everything there. So I said, okay, hold my beer.
That would have been my first thought, would be not hold my beer, but would be how, like I said, how in the hell are you going to get that, the complexity of what those signals are? How are you going to do that? But you've explained
you
how
cannot. You can't, and because it's impossible, it's pointless to try.
Yeah.
This thing is only viable if it's simple mixtures, and the simplest one is a single compound. Yeah. So now I've proved that mammalian behavior can be manipulated by single components, which was supposedly impossible, right? So if anybody wants to kind of stamp his name on something which will create huge benefit, both economic and ecological, stamp his name on that as an impossibility. That became possible by the bioboundary wild scent project would be the one for him. I mean, these guys who spend millions shooting rockets up, that had been done before.
Yeah.
Nobody said it was impossible, right? It was basically, okay, I'm going to do it. This is my rocket. It's not, this is something that nobody says can be done. Whereas what I'm doing now with these deterrents is stuff which was previously considered to be absolutely impossible.
Yeah. That's
You know, like
what I
it's the
personally as well.
perpetual motion.
It's
Uh,
it's incredible. I mean, you're doing it, so
yeah,
obviously you come across your own
it's
successes and your own joys and everything. But from an outsider's perspective, I would be that person who would think, how in the hell are you going to do that? That would I can understand that, but to actually see it, that's what captivates me when I look at not just the camera trap footage that you do, but the paper that you put out and the work and the successes that you're having in speaking to you now. It's like a trailblazer, really, isn't it? Oh, you're speaking to somebody who's taken something that somebody said you'll never do that and done it, and it's sort of like, please
yeah.
give me the funding to prove it further and take it further, for the right reasons as well, which I think it. I've, I'm I have no words personally. I think it's phenomenal. I think it's absolutely phenomenal.
It is, and it asks, like people say, it's a cliche. Good science asks lots of questions. Is I've got a huge number of camera trap videos of animals doing odd things around scent, which will make wonderful follow-up projects for students in academia if they wanted to do that. And we desperately need, as a kind of underpinning to what I'm doing, is way more knowledge about how mammals are communicating by chemicals.
Right.
Um, and and that is definitely doable under the current academic paradigm. The projects need to be properly designed and structured, but it would make wonderful MScs and great PhDs. But somebody has to pay for the students to do it. The resources have to be available, and at the moment they're not. And the main thrust, the people who are still working on mammal chemical communication, they're all working in the lab with model species. I hesitate to say nobody at all working on wild species, but there's very, very few of them. Um, and it's very challenging.
Yeah.
But with the modern technology we've got, the GPS collars and the accelerometers, all this kind of fancy stuff, and the camera traps, the remote monitoring, plug the analytical chemistry into it, it is way easier now, way more practical now to do it than it was. So, well, in fact, in the 1980s, it was utterly impossible to do the field work because we just didn't have the technology. Now we do have the technology, but everybody's lost interest. A whole bunch of the people who were working on mammals have gone working on birds now because they also communicate by chemicals, surprisingly enough.
Right.
But they're now recreating the early work on mammals, and they're going to run into the same problems with actually what are the active ingredients and can we recreate the signal artificially to test it explicitly. They just get into the stage where they're going to run into the same problem as the mammal people did. And then they can go and work on lizards or something. There is a lot of work on lizards also.
Start again. Start again.
And strangely enough, snakes. Snakes do quite a lot by chemical communication.
Really?
So there's a fair bit of work there. Yeah. And I mean, there's another potential application. Everybody says there's no such thing as a snake repellent. But snakes are very olfactory creatures. That's what they're doing when that tongue is going in and out like that. They're sampling odors. And
See,
an animal that spends so much time sniffing, I'm reasonably sure you can manipulate its behavior with the smell. But everybody says there's no such thing as a snake repellent. So, okay, so there isn't.
yeah, well, there's
Because
no such thing as a
everybody
leopard
believes there
repellent.
is no such thing, so nobody goes looking for it.
Yeah. Yeah.
And so you go around in this little circle where it's actually like this, spiral downwards into nothing getting done.
I
We need,
remember
we
having
need a
a
kind of belief. People have lost belief. They've lost faith in innovation and new ideas, and let's give this a try.
haven't they just in a lot of areas? But I mean, I
Yeah,
remember having a conversation with a Zoom chat with an Australian politician. I won't say which state it was in or anything like that. And we were talking about electronic collars and dogs and livestock predation, and the value in the tool just for that, and wildlife, chasing wildlife, etc. And one thing that politician was particularly keen on was discussing how potentially going on to discuss how that sort of technology might be used to protect and deter dingoes from
Mm.
basically entering certain areas. It's the same sort of thing, taking livestock animals, but in order to protect them. But what you're talking about there obviously would be able to be manipulated, adapted to different
Yeah.
species, and come up with the same. So the actual potential benefits of this literally would bounce way beyond
Yeah.
Africa, to your wild cats or whatever, to areas around the
Yeah.
world where there are endangered species that are suffering at the potential or the reality of predation by predators.
Yes. Oh, and I mean, we've already extended to Nepal with tigers and leopards. Dingoes would be another one. And in fact, now there's work going on in Australia looking for a chemical deterrent for dingoes.
Right.
Now, by coincidence, people who are working on it used to work for Botswana Predator Conservation. There's work in Europe going on looking for collars on sheep or cattle to keep wolves away. There's 4 different programs, one in Greece, one in Italy, one in France, one in Switzerland. I think there's actually 2 in Switzerland. 3 out of those 4 are people who are previously connected with Botswana Predator Conservation.
Wow, yeah, right.
So we're getting beyond coincidence here with this stuff. But the
That's incredible.
most interesting thing is none of them have got a working deterrent.
But you
And
have.
they've got huge budgets. They've got massive budgets, government backing, the whole lot. Commercial companies involved, and no success so far.
So you're confident that with
So,
the right backing, with general
well,
genuine investment, you can,
I mean, I've got where I am with kind of just enough funding, and with a team which up until September this year was basically me and a field assistant. This is on the deterrent side. It was me and a field assistant whose highest level of schooling was he left primary school. So so imagine what can be done. What we need is a team of complementary specialists, right? So we
yeah,
get to critical mass. There needs to be top flight natural products labs involved to identify the components of the sense. Because in my little lab in Maun, I can get kind of 90 and some percent of the stuff identified. But it's actually the unidentifiable ones that are the most interesting because they're plainly not ordinary chemicals. That makes them intriguing their potential signals. But I can't identify them. I need collaborating laboratories with way fancier instruments
okay,
and people who know more chemistry than me on the team. I need specialists to design monitoring collars so we can detect when animals are scent marking, for instance. I need people to design the controlled release dispensers, which can be produced by the tens of thousands for the final commercial production. Now, that stage is actually fairly easy because those are already being produced for insect pheromones.
right,
So
okay,
that's just a case of kind of plugging into existing technology. But it needs a whole slew of specialists all tied together in a kind of virtual worldwide team. Data processors, all of this stuff, some of which I don't have the skills to do, a lot of which I don't have the time to do.
yeah,
And then things will really start to tick over. Then we can really start to look at, okay, let's focus on black-backed jackals, which are a huge pest. Caracals, a kind of medium-sized red-coloured cat with the tassels on its ears. Huge problem for small livestock in southern Africa. Let's expand it to one of the pest canids somewhere else in the world. Pick one, aim for it. There's the New Zealand predator-free by 2050 program.
yeah,
There's millions of dollars going into that. And basically they want to eradicate introduced predators because long-term, that's the most cost-effective way of solving the invasive predator problem. It could contribute to that. They've got dingoes in Australia are a problem. Well, dingoes, foxes, and feral cats.
mm,
and they're spending huge quantities of money. There's island eradications for invasive predators, which they come with price tags of $1 million a pop routinely. And this can contribute to all of those. It might unlikely to be the magic bullet that completely solves all those problems, but it can certainly contribute to all of them.
It's
And
certainly a
make the
non-lethal,
run.
it's non-lethal bullet, isn't it? In comparison to a lot of the
Well,
lethal alternatives.
yeah, but I mean, for stuff like, say, eradicating an
Yeah.
invasive predator on an island, it would be to design a lure to either get them into a trap or get them to eat some kind of poison bait. And as a spin-off from looking at responses to the components looking for repellents, I've also got a handful where the animals get into this really focused chewing at the dispenser housings. They're really quite frantic to get inside there. So that would make a very good bait kind of lure. And you can use those for vaccines as well. So if you want to vaccinate, I don't know, you've got a rabies outbreak in hyenas. You want to vaccinate the other hyenas against the rabies so it doesn't spread into the vulnerable populations like African wild dogs. But you don't want your bait getting wasted by being eaten by other stuff. So you find one of my chemicals, hyenas go crazy for it. And it's actually something which is readily available, cheap and easy. So you put that in a nicely flavored thing, but which is too hard for anything else to bite open. And then you vaccinate only the hyenas with broadcast baits and so on and so on. So there's a huge, huge number of spin-off applications that we can also
I would
get.
have never thought. I would have never thought of something like that. I'll be completely honest with you. The idea of thinking, vaccinating wild animals, but how do you go about doing that? I mean, the first thing that would come to my mind, and I should imagine most people's mind, is a dart gun. To try and do it via a dart gun, but to actually lure them into, just by simply using scent, to lure them
Yeah.
into a trap where they can be vaccinated, released straight away is
Well, the
incredible.
idea is it's an oral vaccine, but you want only your target species to eat it.
Yeah,
So you need to design what you want is a species-specific attractant
yeah,
and some kind of container which is of appropriate size. I mean, there's a whole huge amount of stuff going on in Australia now about targeted baits for feral cats and foxes, because of course they want to kill off these invasive predators to protect the local marsupials.
yeah.
The last thing you want is that the local marsupials are eating the poison baits. They're designing these baits of particular sizes and shapes and smells, all kinds of stuff going on there, in order that when they broadcast them, it's only the foxes and the feral cats that pick them up and eat them,
Wow.
not the local marsupials. So there's a lot going on and huge amounts of money being thrown at it
Yeah,
by
yeah,
various
yeah.
agencies. And the bioboundary use of wild scents as deterrents can contribute to that.
Yeah.
The dingoes would be a good one because plainly there's arguments about, are they really native to Australia? Did they come across with the first people that got there? Yes, probably they did, but they are now embedded in the ecology, and they're certainly very good at suppressing the numbers of invasive predators like foxes and cats. So a non-lethal protection for livestock against dingoes would be very attractive in Australia.
Yeah.
In New Zealand, they would be looking at lures and baits and trap lures, that kind of stuff, which is a similar approach.
Yeah.
And there's been people there have made interesting kinds of breakthroughs in terms of do baits get more attractive if you make the smell stronger? Well, no, actually, they don't. There's a kind of sweet spot. If the smell is too weak, it's no good. If it's too strong, it's also no good. You need to understand where that sweet spot is in order to have the maximum attraction. And I suspect there's something similar going on with some of the deterrents. That if it's way too strong, that is obvious to the animal that this is not a chemical signal.
Yeah.
It just isn't, this is bullshit.
Yeah.
This is just I don't know whether you've heard of Uncanny Valley, where if robots look really like humans, people are fine with them. If they look completely like robots, people are fine with them. There's this, what they call an uncanny valley of a robot which looks kind of like a human, but enough like a robot to make people uneasy.
Yeah.
I think we've got, probably there's the same thing goes on in chemical communication, that there's sweet spots. You need to get it right and then it will work. I mean, my next jump I've got to make is to start mixing things together. So we got multiple components to see if that enhances the activity. So yeah, that's
To be able to
to
push
do
that
that. I
forward.
need resources.
I was going to say funding wise, you know, and obviously the more resources that you need, and the bringing in the more specialists and the access to more equipment and everything. How much at present, with the funding you got at present, how much longer do you have? You know, what's viable in terms of the work
Well,
you do at
this
the moment?
the Wilderness Impact Grant keeps me running probably till about this time next year,
Right.
and we got some bureaucratic holdups with our permits at the moment, which means that can't now raise funds because everybody asks, "Do you have a research permit?" And
So
strictly,
there's
we don't.
nothing. That's what I was going to ask you. Is there anything that anybody outside of, you know, a well-to-do entrepreneur who can donate to you, or, you know, somebody who can actually donate a large sum of
Or
money to you?
invest.
Is the
A donation. Yeah, a donation would be wonderful,
Yeah,
but in some ways, an investment would be better
yeah,
because then people start to take it more seriously.
yeah,
It becomes okay. No, that person really does believe we're going to get somewhere because he's invested. He's not just, oh, here's some money, go and play with it, kind of.
yeah,
But having money to play with would also be great because then you can kind of try some things that is a bit of a long shot, but let's give it a go
yeah,
because if it does work, the benefits are huge.
yeah,
The benefit to cost ratio on most of this is quite unbelievable. I mean, read fundamental research in general, it's something like 150 to 1. This is probably higher than that, as long as we've got resources to kind of try the unexpected, the unlikely, the stuff that looks like that's never going to work. Oh, well, let's give it a shot. But you've got to have the resources to let's give it a shot.
yeah,
Um, and also, those resources need to come without the expectation that if it doesn't work, somebody messed up. It's just, this is a long shot.
yeah, yeah, yeah.
Maybe
It is
it's,
what it
maybe it
is.
doesn't. There is, yeah, there's, please don't be disappointed when we're taking this long shot and it didn't work.
Yeah,
But no, we now, at least now we know that doesn't work.
yeah. But
Um,
you've got to take the long shot sometimes, haven't you, to
well,
see?
basically, yeah.
You know.
Um, but that isn't part of the kind of current mindset. There's actually quite a bit of writing and speculation in science in general. The rate of innovation has dropped sharply since about the 1980s. So a continual downward decline in actual kind of breakthrough science and genuine innovation. And nobody seems to know why. My speculation is that the funders are unwilling to kind of throw money and hope for the best. That's partly because the taxman is looking over their shoulder, telling them they must invest prudently, otherwise they don't get tax relief. So
Yeah.
they're reluctant to say, well, give this a shot. If it doesn't
It
work,
works.
it
It
was
works.
only
If
$1
it doesn't,
million.
it does. Yeah.
The taxman is saying, you screw that $1 million away, you can't have your tax relief on it.
Yeah. Yeah.
Um,
What a state of affairs.
that's my speculation on why, in general, this is the whole of science. Strangely enough, including stuff like AI, which actually AI is an extension of stuff where the innovations were made back in the 1980s. Is everything is just development of stuff which people already knew about and which it's predictably going to be a success of varying sizes, but everybody knows it's going to work. And pretty much they've got a timetable for it. So,
Yeah.
okay, we'll invest in this because it's going to probably pay back better than the stock market. And as a consequence, innovation, genuine innovation, uh, is very limited since about the 1980s. And sooner or later, that is going to come back and bite us because the problems haven't stopped getting more complicated. And sooner or later, our existing solutions are going to run out. So yeah, there does genuinely need to be some kind of support for breakthrough innovation.
Yeah. Innovation. Well, I mean, I'm absolutely, as far as I'm concerned, that covers everything really that I was, I was hoping to get out of speaking with you, because the insight into the work that you're doing and your background and detail that I was personally completely unaware of. I can't see how anybody would fail to be, massively impressed and
Yeah.
supportive of the work that you're doing. I don't certainly anybody who claims to have any interest in animal well-being, animal welfare, whatever, conservation, preservation of, it's just it's incredible to me, and I get a sense of, or I would have a sense of, if I were you, frustration that there is not more, not
Yeah.
recognition of self, but recognition of what you're on the cusp of potentially being able to actually produce, and the benefit of producing that on a global scale, across multiple, like you're saying about, delivering vaccines, that, things that you wouldn't think of, but you think, Christ, the actual potential implications of this and the benefits of it are massive, massive.
Yeah. Chemical communication is the most important communication channel in all mammals except humans. And even we do quite a lot of
Yeah,
more, no, more than we consciously aware of. It is by far the most important communication channel. And that means it's almost also the most powerful way that we can manipulate and manage and help and eliminate pests and all kinds of stuff. But it is technologically extremely challenging. It's by no means impossible. I've proved that. But it is challenging. And it is, at this stage, we don't have a solid enough foundation about mammals in general, wild ones as well as lab model species, in order to be able to say, okay, so if we did it like this, we'd come up with a product that could do that. That foundation is not there. And if there was a huge amount of money available, part of that should definitely go to building the foundation, to pick some species. Like black-backed jackals would be one good one. Pick a medium-sized cat, African wildcats for a smaller cat, look at some of the weasels and that kind of stuff, and work in detail on their chemical communication using all the technology that we've now got available, so that we build a foundation for using chemical communication in mammals in a similar way to what it's been used in insects, for instance, where it's a massively powerful technique for particularly pest management, but for mammals, there's all kinds of other things you can do, like enhancing reproduction. So in farm animals especially, you get these males which have got the fantastic meat producers, all kinds of stuff, but they got zero libido. So you need some, maybe you need a perfume for the lady pigs to
I was
to
just going to
enhance the
say,
guy's
Peter,
performance.
I do not understand why the human perfume industry isn't clambering all over
Well,
what you
okay, you
do.
see, yeah, but this is one of these other odd things. So, if you've got a few minutes to waste,
Mm.
just Google human pheromones, and you'll get millions of adverts for stuff which is basically bullshit. And this kind of goes back to the 70s and 80s as well, where people got the idea that that male hormones or their breakdown products were aphrodisiacs. They would drive women wild and they'd throw their bodies at you. You've seen the Axe adverts.
Mm.
So these things were commercially produced, and they don't work because they don't have the right compounds in. And it's a simplistic view of of mate choice
Yeah.
communication anyway. There's a whole bunch of stuff on mate choice in different species, including humans. There's way more to it than you just slather yourself with one particular compound. Doesn't work like that.
Bit of brutal
And
doing.
of course, well, yeah, or Old Spice, that's more our generation. Anyway, so, but the problem was, okay, this is all bullshit. So it makes people look askance at the use of chemical signals for other applications.
Yeah.
No, their fixed idea is, oh, pheromones, that was bullshit.
Yeah.
So then it's
So you
bullshit
said, yeah, so you've got sort of like preloaded
When App
mindset.
says he's going to when App says he's going to protect livestock using chemical signals, there's bullshit as well, because back in the 80s
We've proven it
there
didn't.
was all, but I mean, they're still, you can buy them over the internet,
Yeah.
and they don't work. Complete waste of time. But what does work, although you can't make it artificial, is that people are romantically attracted to people whose odor signals that their immune systems are complementary.
Wow.
Same as in mice. But of course, that's an individual feature.
Yeah.
You can't spray it on.
Yeah, you can't sell it.
So there's no commercial application for that. But yeah, it's human pheromones. Yeah, it's a field which kind of poisoned the well for the rest of us to a large extent.
Well, I mean, I'm absolutely, like I say, I'm delighted to have spoken to you about the work that you're doing. I think it's absolutely fascinating. I genuinely hope that some investor will look at it and think, yeah, I'll take the plunge. This is something that's well worth it, and it could, stamp my place in time, if you like, for having done so. The results from what you're saying, absolutely astounding. From somebody who's with domestic dogs, companion dogs, and today out working today with people to prevent livestock predation by dogs.
Yeah,
And it's not just from the predator point of view, it's from the prey animal point of view as well, and the protection of both, and making sure that both,
yeah,
live as well as they can do, and die as humane a death
yeah.
as they can do as well. So I totally and utterly get it. I really, really get it. And I hope that anybody else seeing this gets it, visits your links, supports you, shares the video, gets as much sort of like coverage of what you're doing as possible. And I thank you, Peter. I thank you for taking the time
But
to speak and to share your extensive knowledge and experience and professionalism.
yeah, well, thank you, Jamie, for giving me the chance.
Fantastic. Thank you very
I
much
know,
indeed.
I know you've got a solid following, so I'm
Yeah, yeah,
hoping
yeah.
some of
Well,
it. Um, I
there's some
mean,
good people.
the, probably the most commercially viable application of any of this will be to stop the neighbours' dogs shitting on people's lawns.
I know. I know. But
So
if
anybody,
it does it, it does it.
so we'll make that the flagship project, I think.